Hi, good morning. I'm Bettina Hausmann, and I'm representing SIAS International, and as well United Nations Association of Southern California. And I'm really proud to be here today with one of my really good colleagues in the fight for sustainability, and that is Doug Hudson. And I was hoping it would actually pull up. It's the ATS. And ATS standing for Advanced Thermovoltaic Systems. And it took me a while to get the thermovoltaic systems really pronounced correctly. Doug, take a seat, please. I like it when he says, yes, ma'am. So Doug and I were talking actually quite a bit over the last few days. And for me, it was the first question, what is thermovoltaic systems, in particular the advanced part of it? So Doug, can you explain to us what that means as we're talking about from heat waste to heat waste as an asset?
Yep. So thank you, and well done on thermovoltaic. At Advanced Thermovoltaic Systems, or ATS, we're taking industrial waste heat and turning it into power. So that's what the thermovoltaic piece is. What we're able to do in this endeavor is do this at a megawatt plus scale. So what this means conceptually, or for, I guess, the non-scientist that doesn't want to say thermovoltaic, is if you think of an industrial plant, say cement, about $1 million of their money to create that pound of cement, $600,000 of that is lost as evaporative waste heat. We're able to capture that and return it back to the plant as actual energy, again, at the megawatt scale. So when you think about this and take it one step further, we're able to impact energy security in a way that provides a clean, consistent source of additional energy to that plant. We're able to help reduce the grid stress. And then by extension, obviously, well, not obviously, but maybe obviously, we're also able to impact carbon or carbon abatement, because if you think about it, one less megawatt of power that factory needs to pull off the grid or combust in a generator now doesn't use that consumable, it doesn't release that carbon.
I have my mic. Thank you.
Oh, sweet.
So what is then the application for the product that you have? What would be the specific application? What's the industry, or who's your partner in that? Who's the customer?
So as I said, waste heat. So when you think about it, waste heat is not just in a cement factory or a plastics factory. It's also in things like data centers. And I think we're all kind of familiar with AI. It's been all over the conference. People have been talking about the advancements in AI and how AI can actually help climate and help solve some of these additional problems. That's awesome. But AI resides on a server. That server is very dense. It creates a bunch of heat. It consumes a bunch of power. So wherever there's waste heat, we can apply our technology. Our technology is about the size, my colleague has it over there. He's happy to walk around and show people, or hand it to me. But the point being is that it's not just industry. It's not just data centers.
Wow, heavy.
It's also things like geothermal. It's also things like flaring. And when we talk about geothermal, there's a lot of solutions out there that use geothermal to generate energy. The problem with that is they're getting 3 or 4 cycles out of that geothermal well, and then they need to pause because they've they've decreased the heat enough that they have to let it resume its level of heat. What we're able to do is about 6 to 8 times using that well more, because even though we're streaming hot on one side of this cartridge and cold on the other and creating power out of it, we're only stripping out about 1% of the heat. So we're able to use those geothermal wells a number of times, 6 to 8 times more than traditional. So from an application, Bettina, This is really game changing because, again, it's not data centers, it's not heavy industry, it's all the way down to things like geothermal. And if we talk about communities, this has the ability to provide power to rural communities that have access to geothermal wells.
And we had spoken about what do you use to produce it, right? And you had mentioned this is a really special byproduct.
Yes, thank you. So we use bismuth telluride to actually make the pellets that are inside this cartridge. There's about 300 of them. Now, what's nice is this is not a rare earth element. This is actually a byproduct that comes out of things like copper mining. So we're not actually contributing to the stripping of the earth. We're actually using a byproduct and helping that local community be able to not just have a big pile of dirt or bismuth telluride in this example, but we're able to consume that, use that. What's really nice about this as well is the way our technology works, it's fully circular. So as we grow and gain efficiency in our cartridges, we actually can take that, recycle it, improve the efficiency, and then remanufacture.
And that's really, for me, the selling point as a consumer. Not that I will put that into my fridge or anything. But with that, I mean, you have, with the data center, you mentioned how it essentially differs from more traditional applications, right? So, or industries in that regard. As we talk about the heat waste as an asset, so the industry has yet to see it to capitalize on. Is that correct? Am I understanding that correctly?
In a way, yes. Traditionally, what industry has done, and this has been for 150 plus years, some of you may be familiar with it, but industry will take today, before us, will actually take that waste heat. They will use essentially that waste heat. They will use hazardous chemicals to spin a generator. So what I like to say is they're using an ORC generator, which contains hazardous chemicals. If you're familiar with generators, it's a big spinning thing. So they're using hazardous chemicals, they're piping this, they're spinning a big thing, essentially blowing something up to create energy. We're able to do this as a solid state generator. So number one, we're doing this without hazardous chemicals. Everything in here is recyclable, it's natural. We're also not spinning something. So from a sound impact as an example, or if you think of a generator, they're putting off exhaust heat. None of that exists with us. So we are much more environmentally friendly and ecologically friendly. Also, when you think about it from a plant perspective or a company perspective, that operations and maintenance is virtually nil with what we're doing. So you don't have to put somebody in a hazmat suit. You don't have to have any of that hazardous either material or environment. This is literally, pardon me, Bettina, literally a plug and play. So maintenance, very low. Environmental impact, really high. When we think about it at a global scale, we're talking about potential megatons and gigatons of abated carbon.
So you've been actually recognized for this technology last year in South Africa at the Earthshot annual. It's an annual event, and explain what was it, why is it so unique and special? Because the company itself is fairly young in this venue eventually, right, or essentially. So what is it about Earthshot? Why is it so prestigious? What did you get? And why?
So 5 years ago, Prince William, the royal family, sorry if you, whatever, Prince William, Bill Gates, and Michael Bloomberg formed the Earthshot Prize. It's a 10-year initiative to really accelerate and promote those technologies that can have the largest impact in solving some of the climate's greatest challenges. So we won this last year. What is unique about about ATS winning is we are the first of a kind, truly industrial, scalable technology. A lot of the other stuff, we saw the gentleman before talk about water, unbelievable product. We're the first one that is actually hard tech. If you look at, again, I'll hold this up. If you look at this, this is not soft. This is not nice. This is hard tech. It's going into the biggest carbon producers on the planet: cement, steel, glass, plastics. So for us, it was both validation that this is a problem and that hard tech can solve these problems. It's also validation that there is a scale opportunity here, and this is at a global and massive level.
The US recognized you as well, right? The Department of Energy, is that correct?
Yep. So we recently won a Department of Energy Industrial Technology Validation Award. We submitted for that along with along with our client that we proved that we can take industrial waste heat and turn it into power. In that award, we said we're going to meet this, this efficiency. We're going to do this. We're going to do this. We're going to do this. In every single one of those tests, we outperformed what we committed in that test.
And then you here at EarthX, and that's also your very first time. What is it that you want to take away, or what do you want us to take away from ATS?
So from an ATS perspective, it's about just promoting the brand. And there's a lot of really good technology out there and a lot of really good concepts from this community. We're looking at it from our ATS perspective at a global level. We're looking to work with, say, the folks in Houston, which is like the center of U.S. power, if you will. We're looking to work with those really hard to abate places. We're looking to have them be able to use their waste heat and monetize it for better plant performance. I think that would be just the brand amplification. I think personally, what I've really got out of this is the connection with the community and hearing about the different approaches and the different ways that people are looking at trying to solve some of these very challenging pieces. And then, at one level down, actually talking to some of these innovators and investors and experts to hear their opinion and to get their insights as to why they're here, what they're doing, and how they see the next 2, 3, 5, 10 plus years, and what that means to us as people on the planet.
And what is the next thing for ATS, the next big step?
Interesting. I would say the next big step for us, right now we're at 14% efficiency. If anybody wants to come talk about it, my sales guy's over there. But I think the next big step for us, besides working on the investment side, is really taking that thermal efficiency of 14% and getting to our goal, which is north of 30%. At that rate, we can talk about things like over the next 5 years or 10 years, being able to abate 830,000 swimming pools filled with oil, or parking every car in the United States for 2 years. So these are the measurable impacts. Those are the next big steps for us.
Thank you so much, Doug. This was really a lot to think about, particularly for somebody that's not that technical, but I'm hoping everyone else has well understood the technology in a sense that you definitely reach out to Doug if you have more questions. So for me, the aspect is really about sustainability and you turning industrial heat waste into sustainable electricity. And as we mentioned, we had EarthX 17 Sustainable Development Goals, and number 17 is the major one that we all need to partner in implementing it, and I think that's the platform what EarthX is offering us. Is there any parting last sentence, a quote or something, Dirk? Because I know you're from cybersecurity. Is there anything from the background that you brought to ATS that might?
I think for me, a little bit on me, I spent 25 plus years in cybersecurity. And about a year ago, I was talking to a colleague and I said, I don't understand why people aren't taking data center heat and turning it into power. My friend introduced me to our founder, and obviously, like, the rest is history, if you will. So one of the things, I guess, in parting is I clearly have a problem, and my problem is that I want to help protect people and do things that will make people's lives better. In cybersecurity, it was protecting your privacy information. I've done it at scale across the globe, and now I've decided on this new venture that I'm going to help people, reduce carbon, hopefully keep us people around longer.
appreciate that in that sense. Thanks so much, Doug. And if there are questions, please come see Doug or Jonathan over there, the gentleman, the salesperson that was acknowledged. Thank you so much.
Thank you, everybody.